So one last type of indeterminate form really comes in three different variations, are indeterminate powers. So these will be limits where we have a function raised to a power that's also a function. And the three types that we'll encounter in this case, we'll have the type 0 to the power of 0, which means that the expression in the base goes to 0, and the expression in the exponent also goes to 0. The type infinity to the power of 0 is where the base goes to infinity and the power goes to 0. And then the type 1 to the power of infinity is where we have the base goes to 1 and the power goes to infinity. Okay. And so the same rule applies here, that in each of these three cases we're able to rewrite it into a form where we can use L'Hopital's rule to evaluate it. So in other words, we're going to have to manipulate each of these to get it into the 0 over 0 form or infinity over infinity form. Okay, so in each case it'll most likely involve some manipulation of this type, where if I've got, for instance, f of x in the base, g of x in the power, I can oftentimes use a logarithm or an exponential function, like f of x can be written as e to the ln of f of x, and then we got multiplied by g of x. And so rewriting this then as e to the ln of f of x over 1 over g of x will oftentimes get this into a form where if it's approaching 0 in the base, then you got something that approaches negative infinity here, and then 1 over g of x would also approach 1 over 0, so that'll also go to infinity. So this will most likely get it into that infinity over infinity form. Same here, right? If I got f of x goes to 0, or sorry, if f of x goes to infinity, then ln of f of x goes to infinity, and 1 over 0 goes to infinity, right? So infinity to the power of 0 will be able to transform into the infinity over infinity form, and then 1 to the power of infinity will be where ln of 1 is 0. So you got 0 upstairs, and then 1 over something that approaches infinity also goes to 0. So that will transform it into the 0 over 0 form. So let's practice this a little bit to see how this manipulation works. Take, for instance, here we've got the limit as x approaches 0 from the right of 1 plus sine of 4x to the power of cotangent x. In this case, I noticed that 1 plus sine of 4x will approach 1 plus 0, so it approaches 1 in the base. Cotan x will have a vertical asymptote at 0, so this will approach infinity. So you got something in the 1 to the power of infinity form. Okay, so we're going to try and manipulate this a little bit somehow. So the way I'll do it is I'll take e to the ln of 1 plus sine 4x to rewrite that base 1 plus sine 4x, and then that will be multiplied by the power of cotangent x here. So this limit as x approaches 0 can be brought into the power in front of the ln. So I've got now e to the limit as x approaches 0 from the right of ln of 1 plus sine of 4x. And then here cotangent x, I'll bring that to the denominator, and it becomes tan x in the denominator. Okay, so now I have something in the 0 over 0 form, because here we got something ln of 1 plus 0, which is ln of 1. So we got something that approaches 0 in the top, tan of 0 is 0, so it's in the 0 over 0 form now. Okay, so it's a little bit of a tricky manipulation, but now that it's in this 0 over 0 form, we can apply L'Hopital's rule. So let's work it out. So after I take the derivative of the numerator and denominator of this expression, ln of 1 plus sine 4x, so that'll be 1 over 1 plus sine of 4x, times the derivative of sine of 4x, which is 4 cosine 4x. Okay, so that was just taking the derivative of ln of 1 plus sine 4x, and then the derivative of tangent is secant squared. So let's simplify this a little bit. So let's see, I've got 4 cosine of 4x, 1 plus sine of 4x, and then secant squared down here. Now, what can we say as the x goes to 0 from the right now? Well, I noticed the cosine of 0 is 1, so we don't get 0 in the numerator anymore. And secant of 0 is also 1, so we get 1 plus 0 times 1 downstairs. So we get 4 times 1 over 1. So this becomes e to the power of 4 over 1. It's just e to the power of 4. Okay, so that's interesting because here, right, we get something in the end that is a power of e. And again, here this used this little manipulation that we did at the very beginning to get it into that 0 over 0 form. Let's try one more example like this. Say I've got the limit as x approaches 0 from the right of x to the power of x. Right, so clearly this one's in the 0 to the power of 0 form. So our manipulation here will do the same exact trick that we did before. I'm going to rewrite x in the base as e to the ln of x, and then times x, right, to the power of that x there, so we'll multiply by x. And then to get this into the form 0 over 0, we'll do ln of x over 1 over x. So now we see that as x goes to 0 from the right, now we're in the form ln x goes to negative infinity, 1 over x goes to infinity. So it's in the infinity over infinity form. So now it's in the form where we can use L'Hopital's rule. So taking the derivative of ln x in the numerator there, we get 1 over x, and then taking the derivative of 1 over x in the denominator, we get negative 1 over x squared. And a little bit of simplifying here. I can flip over the negative 1 over x squared, so we have negative x squared over x. And that simplifies to just negative x, and so as x goes to 0, we're left with e to the power of 0, which is 1. So there we have it, that as x approaches 0 from the right, x to the power of x is going to go to 1.